everybody, welcome to Solving Logs and Exponential Functions. I'm sure it's a favorite of yours since most of it is review from last year, Algebra 3-4. And I know that last year in Algebra 3-4 you're like, oh my gosh, this is so hard, I panic so much, I can't stand logs, I have all this log anxiety. I'm here to tell you today that it's not going to be hard, everything's going to be fine. By the end of the video you'll think, oh, that's so easy, how come I thought it was so hard? So what you should do is, I put on a little note-taking guide. You should print this out. It's just 4 squares that you're going to have to decide what functions to put where. And then there's a whole list of functions. There's 8 here, but I think I'm only going to do 4 because you guys might get a little bit bored watching me for so long. Or if I do the first 4 and maybe I'll keep going, but if you get it, just stop because you're like, I can't stand watching you anymore. I get it. Okay. So the first thing you need to do is realize that there's only 4 types of functions that you can solve. Functions that have exponents and functions that have logs. And the way that you can tell the difference is you see logs in the equation or you see exponents in the equation. And I'm not talking about exponents like x squared, x to the 5th. I'm talking about variables in the exponent. That's what makes it exponential, right? So then if you see exponents, the way you solve it is that that's also divided into separate categories. If they have the same base, then you just write them as the same base and set the exponents equal to each other. If they have different bases, then you're going to have to use logs. Don't freak out, don't freak out. Get your calculator out now because you're going to need it. And then logs will be separate. So let's see, let's print out your paper and let's get started. So the first problem I see is 4 raised to the 5x plus 8 and 1/8 raised to the 3 minus 2x. So I know when I see 4s and 8s and 16s and 32s, numbers like that, I know I can write them all as powers of 2. So that's going to be a situation where they all have the same base. So I'm going to put problem number 1 right here. So 4 raised to the 5x plus 8 equals 1/8 times 3 minus 2x. So I see exponents, and I realize I can write them all as a power of 2. So 4 is really 2 squared. So I'm going to say that this is 2 squared, and then times that by 5x plus 8. Oh, okay, so now that whole thing becomes the exponent. And 8 is really 2 cubed, but because it's in the denominator, we bring that up to the numerator, so the exponent really becomes negative. So that's 2 to the negative 3 times 3 minus 2x. Now it's a piece of cake. The exponents are the same, or the bases are the same, so all I have to do is just set the exponents equal to each other. Set this equal to that. So I'm going to distribute, so 10x plus 16 equals negative 9 plus 6x, and then I'm going to combine x's, so I get 4x over here is equal to negative 25. So I get that x is equal to negative 25 over 4. Wow, that's not very hard. One little step right there, and then it just becomes basic algebra. Easy. Okay, I like this. Let's look at problem number 2. I see logs. So I'm going to move over here and think, are there logs in every term? I see a log in the first term, I see a log in the second term, but I don't see a log in the third term. So they don't all have logs. So I'm going to put number 2 in this category, not all logs. So 2 times the natural log of 3 plus the natural log of x plus 4 equals 1. So in order to solve something that has not all logs in it, it's the same situation that we're going to do over here with the logs. The first thing that I need to do is squish everything in together. So I need to get all of the logs together. So just like I would do with the other equation. So I can bring these 2 together, but before I bring these together, I have to bring the 2 up. So I'm going to use the power rule and say that that's really the natural log of 3 squared, which is really the natural log of 9, plus the natural log of x plus 4 is equal to 1. Now my next step is I'm looking at this and I think, okay, I'm adding these 2 logs together, so what I really have to do to combine them into one log is addition. Means all I have to do is write them in one log and multiply. So that's 9 times x plus 4. Oh good, I get to distribute there. That's going to be fun. Equals 1. Now I have everything all nicely compacted into one log over here and some number over here. That's exactly what I want. So when I have nothing in front of the log, and then when I have the number over here all isolated by itself, now all I have to do is change the base. So the base that I want to change to is, what is this base? Well, this is base e, because it's natural log. So I'm just going to change the base. And then the properties of logs that we learned last week, these are just going to cancel each other out because they're inverses. So this whole thing just becomes 9x plus 36 is equal to e. E is just a number like pi. So I'm not going to use my calculator right now because it's all the way on the other side of the room. If you want to work with decimals and write this as a decimal, that's okay. But you don't need to. So I'm just going to say 9x is equal to e minus 36. So x is equal to e minus 36 divided by 9. And you can leave your answer like that, or you can write it as a decimal if you don't like that. I know some of you panic when you see things like that. Okay, so that's not so bad. So I have to squish all the logs together using the log properties and then just change the base. So if this was log base 2, then right here I would change this to base 2 and change this to base 2, and so this would be equal to 2 over here instead. That's not so bad. Let's look at problem number 3. I see more logs. Oh my gosh. Okay, so I see a log in every single term. So I'm going to put that one over here. Logs in every term. So log base 3 of x plus 6 minus log base 3 of x minus 2 equals 2 log base 3 of 4. Now, what's going to happen here is I need to do exactly the same thing. I need to squish them all together as much as possible, and then, but unlike this problem over here where I ended up with a number, I'm going to end up with logs on both sides. So this one's actually even easier, even though it seems scary because you're like, oh, there's logs and everything. So log property, if I'm subtracting, then that means that all I have to do is divide. So x plus 6 divided by x minus 2 equals, and then I'm going to bring this 2 up, so log base 3 of 4 squared, which is 16. Now, look at this. I have logs on both sides. So I know what you all want to do is you just all want to cancel it out. And basically, that's what you do. But mathematically, it kind of tears me up a little bit when I see you do that. So what we are really doing is still changing the base, except both of these things are going to cancel out now. So I'm going to change it to base 3. This is going to cross off, and this is going to cross off. So I just have the easy algebraic expression to solve right here. So I'm going to cross multiply. I get x plus 6, and I'm going to distribute that. So it's 16x minus 32. So then I get 38 is equal to 15x. So x is equal to 38 over 15. Now, there's a little situation right here that we didn't talk about, because I was just looking at the answer to that problem over there, and it scares me a little bit. Anytime you use logs, you really have to be careful with your final answer. You always have to check your final answer. Because remember, you can't log a negative number. So if I end up with some number right here that when I plug back in here makes this negative, it's going to be bad. So if I take a positive number and add 6, I'm okay there. This number is bigger than 2, so I'm okay here. That's going to be positive. So this is really a solution. Because I'm going to have all values greater than 2. This is bigger than 2, so I'm okay. Over here, though, x has to be greater than negative 4, right? Because I can't log a negative number. So if x is not greater than negative 4, then this is going to have no solutions. So what's e minus 36 divided by 9? I'm a little bit afraid I'm going to actually walk all the way over here and get my calculator I wouldn't hate for you guys to find one that has no solutions and be like, oh, Miss Krebel never told us about that. So, in parentheses, e minus 36, so let's see, e minus 36 is negative 33, divided by 9 is negative 3.7. Okay, so let's see, is this good? This is about approximately negative 3.7. So that's true that that is bigger than negative 4, so this is fine. Whew, that's scary. Remember, you have to consider your domain for logs, because you can't log a negative number. So let's try the next example. Problem number 4. Oh, I see exponents. And, I don't know if I can write it in the same base. So I'm going to just start with it over here. So 4 is equal to, number 4 starts with 4 too. 4 plus 2 e to the 3x plus 4 equals 18. All right, now, don't get crazy and think that you can add these two things together and call that 6, because you can't. This one has an e attached to it. This one has nothing. So this has to go over here with the 18. So I'm first going to subtract 4 from both sides, because I have to isolate this base. So 2e to the 3x plus 4 is equal to 14. I still have to get the e all by itself, or whatever this base is all by itself. So my next step then, divide everything by 2. So I get e to the 3x plus 4 is equal to 7. Okay, now see how I have this base right here? It's isolated. It doesn't have anything in front of it. So when it has nothing else in front of it, then I can log. So over here, what I did was I changed the base, which was kind of like exponentiating something, if that's a word. Over here, the way that I solve these things is I log them, because logs undo exponentials. So which log am I going to choose? Well, if this is base e, it certainly makes sense that I'm going to choose the natural log, naturally. I mean, if I log the left side, I have to log the right side. So then, what happens is you can bring the exponent down, or you can think about those just canceling each other out. So I get 3x plus 4 is equal to the natural log of 7. And you can get your calculators out if you want to, or you could say that 3x is equal to the natural log of 7 minus 4. So x is equal to the natural log of 7 minus 4 divided by 3. And we don't care about positive or negative numbers with exponentials, because the domain of exponentials is all real numbers. You can plug anything in that you want. So the key here is that you need to decide if you see an exponents in your problem or if you see logs. If you see exponents, see if you can write them as the same base and just set the exponents equal to each other. Or if you can't, isolate the base and then log both sides. Okay? For logs, the two situations you have are you have logs in every term, or you don't have logs in every term. Either way, when you see a log, you have to start condensing it with your log properties, squish it up as much as you possibly can, and then change the base. And then it's just a matter of solving easy algebra problems. Okay, so you have 4 more problems to do on here. I'm going to keep doing them, but if you don't want to listen to me anymore, just stop the video. I mean, I'm sure that you're all going to watch it, but just in case. Practice them on your own, and then you can speed to the end and check your answers. Okay, so let's look at problem number 5. Ooh, logs in every term. So that's going to be over here. So number 3 and number 5 are both the same. So 5, the natural log of x plus the natural log of x plus 1, ooh, I like this one, is equal to the natural log of 6. So I'm going to squish them together. The natural log of x times x plus 1 by multiplying them equals the natural log of 6. I'm going to change to base e. Those are going to cancel out. So x squared plus x equals 6. Oh, this is fun. It's quadratic, so I have to factor that. Yay! So I get x plus 3 times x minus 2 equals 0. So x is either equal to negative 3 or 2. So logs, I have to check my answers. -3 isn't going to work because I can't log a negative number, but 2 is fine, so my only answer there is x is equal to 2. Yay! The next one, I see a log. Oh my gosh, but I only see one log, so it's going to go over here. Okay. So this one doesn't seem hard at all. This actually seems easy. So 2 plus log base 3 of x equals 4. So I got to get the log, got to get it all by itself. So I'm going to subtract 2 from both sides. So log base 3 of x is equal to 2. Now this is just like what we were doing in class. Remember, I can change this to an exponential by writing it as 3 squared equals x. So x is equal to 9. Or, if you want to think about it the way I told you before, log base x of 3 equals 2, change the base to base 3. Those cancel out, so x is equal to 3 squared, which is the same thing, 9. Yay! Okay. Ew. 7, I see 32, a fourth, and 2. I bet I can write those all as powers of 2. Or maybe powers of something else. Let's see. I bet I can. I'm confident. I'm feeling good about this one. 32, but I am a little bit afraid of fractions. So 1/4. Ooh, double fraction. Ah! Okay. So I'm going to divide both sides by 32. I'm not going to freak out that that's a fraction. So on the left-hand side, I get 1/4 to the x over 3 equals 1 over 16. Now, I know I can write this as a power of 2, and this is a power of 2, but since this is a fourth, I can write this as a power of 4 also. So you can be a little creative, you know, x over 3 is equal to 1/4 squared. Oh, easy. Now they have the same bases. They don't have to be the smallest possible bases, just whatever ones turn out to be equal. So this is easy. X over 3 equals 2, so x is equal to 6. All right. Last one, I bet, is going to go in this category because I haven't done another one of these. So, oh yeah, number 8, look at that. 3 to the x minus 2 equals 2. Well, I can't write these as the same bases because 3 and 2 are two totally separate numbers. So the only way I can solve this is to log both sides. Now, this is when you have options. You can choose whatever log base you want. You can choose log, you can choose natural log, you can choose log base 85, you can choose log base pi, whatever you want. I'm going to use natural log because I'm from Santa Cruz. We're so natural. And then I'm going to bring this whole exponent down, but whenever you bring the exponent down, make sure you do it in parentheses. So x minus 2 times the natural log of 3 equals the natural log of 2. And then I don't want to distribute that all the way through. Oh, forget it. So I'm going to divide both sides by the natural log of 3. That's going to cancel out. I hope you can see this color. I was just thinking maybe you can't. And so I get x minus 2 is equal to the natural log of 2 divided by the natural log of 3. So x is equal to 2 plus the natural log of 2 over the natural log of 3. Ding, 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 ding. And that's it. You're done. Yay! Go watch some more videos on math. Woohoo!